Good. So let's record. All right. Okay. So, Randy, you can see my whiteboard, right?
Yes, I can.
Perfect. Hey, Alan, I see you in there. I know you can't quite connect to audio yet. It still shows you're connecting. But what we're going to do is just go over some problems from section 4.1, and then with whatever time I've got left, I'll do questions at the end. Okay. So, when you first get into your homework, you're probably going to see some instructions that say something like this. Find the implied, can't write very well on the screen, so y'all don't make too much fun of my handwriting. Find the implied domain. And so we're going to talk about, and I know we've been talking about some words called domain and range, but on the ones that say find the implied domain, you really don't have to then go on and find the range. The domain is really the only thing that you have to worry about. And so we're going to look at a couple of different aspects of this and a couple of different problems. So I'm going to call that like a problem one, I guess, and then I'm going to give us some different functions. Just because your homework is kind of randomly done and everybody can have things that look a little different. So I'm trying to kind of cover all of our bases here. So on this first one, we're going to look at this. So f of x is equal to, and then that's the square root of x minus 5 is all underneath that square root. And then I have a plus 3 on the outside. So the trick to this one, there's really two ways that you can do it. You can either look at a graph. We'll talk about that in a little bit. What I'm going to do is approach this one from a more algebraic standpoint. So if you'll remember, there's kind of like a cardinal rule, and it's this. You can't take the square root of a negative number. And I always tell students that if you don't believe me on that one, grab your calculator, plug in something like square root of -4, and it's going to tell you that there's an error there. And so that rule means what we need to do is take whatever is underneath the radical, and in this case, I'm going to kind of circle it for you. This is what's underneath the radical. So we are going to take x minus 5. And since we know it can't be negative, we're going to say it has to be greater than or equal to 0. And you always, that's really important. So if you're taking notes, you might want to stop right there for a second and make sure you realize it's always greater than or equal to 0. I don't care what's underneath that square root. You always take what's underneath the square root, make it greater than or equal to 0. And then you solve it. So in this case, to get the x by itself, I'm going to write kind of small so that I can kind of stay on the screen here. We're going to put a plus 5. That -5 and plus 5 is going to cancel. So we get x is greater than or equal to 5. Now, if this was, let's say, a written exam and you were writing it on paper, you could leave it like that. But Hawks goes a little further and they say that you have to put this in interval notation. And I know that in this class we've already talked about interval notation again or before, but we're going to talk about it again. So if you think about this for just a second, I'm going to look at a number line. On one side, we have negative infinity, and on the other side, we have positive infinity. And we have all these numbers in between here. Well, we know 5 would be somewhere on there. And the reason I picked 5 is because in our problem, we have x has to be greater than or equal to 5. So x can be 5, or it can be anything on this side because it said it had to be greater than it. And so the way that we can use that picture that we've got to translate into a interval, we start at 5 and we go all the way to infinity. And then all you have to worry about from here are your endpoints. And if you'll remember, a bracket means that you can include the number, and a parenthesis means that you can't include the number. So since our solution says equal to 5, we can include it. So that's a bracket. And we can never include infinity because it's not an actual number. The rule is you always put a parenthesis on infinity. So this, I'm going to circle this right here, would be the implied domain of that problem. Now let me stop right there for a second because I know I've got 3 of you in here. Anybody got any questions, opinions, anything that I need to go back over on that specific? We're going to still go over implied domain, but what about that specific one? Okay, I'm going to take the silence as we're good, okay? All right, so let me erase this, and I'm going to leave that find the implied domain there because we're just going to do it with a different problem. Okay, so I'm going to call this B. And this time I'm going to give you something like f of x equals, let's say, x squared plus 2. Now, you can think about this in 2 ways. The last way, we only thought about it in what I'm going to call the algebraic way, and we're going to start with that one, but then we're also going to transition and talk about the picture orientation as well and see which one maybe you prefer. Some of you may like one way, some of you may like the other way a little better. So if we first think about it, nothing but algebra, so no graphs, no pictures, nothing like that, I want you to realize this problem has no square roots. Now, on the last problem, we had a square root, and I want to be really clear. It has a squared. You'll notice it has an x squared, but remember, a square root looks like this. So the problem has no square roots, and that's important because we know when something has a square root, we had to do what we did last time, set it greater than or equal to 0. And it also has no variable in the denominator. And that's the important part. I didn't say no variable, but it's got no variable in the denominator, which means it's not divided by anything. We don't even have a fraction up there. And so anytime that you have a function that fits both of those rules, the domain or the implied domain is always all real numbers. And the way that we say that is negative infinity to infinity. So any single function, and we're going to look at another one in just a minute, but any single function, if there are no square roots and no variables in the bottom of a fraction, your domain is always this right here, guaranteed, okay? That's it. Now, the bad thing about that is that's a rule to memorize, and we have a lot of rules. And so a lot of times it's a little hard to memorize all the rules, I know. So let's think about this in terms of a picture. And some of you are going to like this rule over here. Some of you are going to like the picture better. We'll just see what happens. So if you were to take a graphing calculator, now I can't really show you a graphing calculator, but if you happen to have one or you use maybe Desmos online or something, if you were to graph x squared plus 2, I'm going to show you kind of an idea of what you would get. It would come right through this y-axis right here at 2, and it would be this shape. So it's a parabola shape, and you can always look at a graph and you can tell what the domain is off of a graph as well. When you're telling the domain off a graph, remember this right here, I'm going to kind of highlight it, run it with my finger. This is your x-axis. And your domain is always talking about your x-axis. So remember, on a domain, you always want to talk about the left first, and then you move to the right. And so if you'll look at this graph, and I'm going to run it off the screen on purpose. As this graph goes this way, It's going up, but you'll notice it's also going way off that. It's also going all the way to the left. And then over here, the graph is going up as well, but it's also going all the way off to the right. And so the way that we know that, I'm going to put a little star down here, is that is once again, all the way to the left means negative infinity. All the way to the right means positive infinity. And remember, since we can't actually touch those things, that means that my endpoints have to be parentheses. Now we're going to continue on, and we're going to do something else that's maybe that's a little different on this problem, but let me stop right there. What do y'all think so far about domain?
I'm good.
You're good? Okay.
Yeah.
All right, let's talk about range. Okay, so remember domain was this one. I'm going to highlight it again. So domain is your x's. Range is your what? Anybody know? It's your y's. So it's your y values. And so I'm going to kind of do this for a second. Range is this one. So if you think about domain being left to right, I tell people to always think about their range as the bottom to the top. And you cannot go backwards, by the way. You can't think about it top to bottom, because when you're writing a domain in a range, it always has to be the smallest number first, comma, the biggest number second. And so unfortunately, and a lot of times people look at Hawks and they think, hey, but I got the right numbers. But if you get them out of order, that will cause you to get your problem incorrect. So if you look at this graph, you'll notice it's that parabola thing. And this right here, this point was the smallest thing that it got to. It didn't ever go any farther below that. And so it got to the point 2. And since it actually touched 2, we are going to put an infinite or a bracket right there. I'm ahead of myself. And then as it goes either to the right or to the left, it doesn't matter which one, but it keeps going up. And so it goes all the way to infinity. And then we are going to put a parenthesis always on infinity. So then I'll just kind of circle this. And that one is your range on this. What do we think so far? Still good?
Still good.
Still good. Okay. All right. So let's try one more that requires us to do a little bit more algebra. And then we're going to flip over to something that looks a little different. And we need to talk about it as well, because you're going to have all of these kinds of homework problems on this section. So, and I'm just going to erase all of that because I made my graph real big.
What section is this?
4.1. So you'll notice that you've already done 4.1. You've done 4.R.1, 4.R.2, 4.R.3, and 4.R.4 so far. Anytime that you do a section that has an R in its name anywhere, that grade actually goes into the developmental portion of your grade. And anytime that you do a section that doesn't have an R in it, that grade goes into the college algebra portion of your grade. So if you make sure when you look into Hawks, don't look at your total grade. Right after that, you should have two different things. One says college algebra grade and one says dev math grade. You actually do, like on your college transcript, get two different grades for this course. We just combined it all into one so that you weren't having to go back and forth and trying to remember which one do I do first and now, and you know what due date is this for that class and all kinds of stuff. So we've separated the grade book in Hawks for you, but I'm going to put, oh, I didn't mean to move that much. I'm going to put a big 4.1 right there. So that way y'all know all of these come out of 4.1, not the R portion, okay? All right, so this one is still going to be find the domain, but it's going to look, so I'm going to call it C again. This one's going to look a little different. So this one says 8y plus 5x equals, oh, we'll just say 4. So you'll notice this one's a little different because of the fact that it didn't say like f of x, or anything like that on the last ones, don't let that bother you. When it doesn't say f of x equals or whatever, all that means that you have to do is first, what you want to do is solve for y. And we're going to do that in a couple of problems, but this is the probably the most simplistic that we're going to do. So we have to get y by itself. So let's look at this. Over here, I have an 8y, and then I have a plus 5x. So what would I need to do to move that 5x over to the other side of my equation?
-5.
There you go. Okay. So we're just going to subtract it. I'm going to put a line right here. And so that's going to drop my 8y. A positive 5x and a minus 5x, those are going to cancel each other out. We're going to bring my equal to sign down. And then normally in math, we write the thing with the variable first. So I'm going to write negative 5x and then plus 4. But if you wrote 4 minus 5x, it's the same thing. It's not incorrect. What I do want to caution you about is you can't say 4 minus 5 and write down a negative 1x. You can't combine the 4 and the negative 5x because one has a variable, one does not. And then you're almost done. You've got 8y, but what else do you need to get rid of to get y by itself?
You divide the 8.
There you go. And I'm going to do this kind of on purpose. You can divide the whole thing by 8, but I want you to realize that you actually have to divide both pieces by 8. And so I'm going to say this is y equals negative 5/8 x. And then we can't write 4 over 8. What's wrong with 4 over 8? What can we do with that?
Simplify.
Yeah, simplify that. So 4 over 8 is the same thing as 1/2. Okay, so we've got it solved for y. That's great. The problem is that didn't answer my domain question. And so you can do one of two things here. You can either go back to our algebra rules that we talked about on the last one. And remember, in this particular problem, there are no square roots. Okay, and there is also no variable in the denominator. Now, there is a denominator. We have an 8 and a 2, but there's not a variable in the denominator. And so if you know that you have no square roots and no variable in the denominator, then that means that your domain is automatically negative infinity to positive infinity. Now, if you don't like the algebra method, once again, you could grab a calculator. You could graph this. I'm going to do my best. I'm going to do a very kind of quick, rough draft. It would actually go through the y-axis at a half, and it would be a line that is sloped kind of down, and it would look like this. But either one of those options should show you that your domain is negative infinity to positive infinity, because notice that my graph keeps going all the way to the left, and it also keeps going all the way to the right. And on this particular one, let's go ahead and talk about range too, just since we're here. Our range is also negative infinity to infinity, because it goes all the way to the bottom and it also goes all the way to the top. All right, so what do we think so far? Still happy?
I'm good.
You're good? Anybody else not? Everybody's good so far? Okay. Y'all don't talk much, do you? Is it too late?
I was about to go to sleep and then I
I just have a baby that usually eats around this time, so she gets fussy.
Oh, I'm sorry. I'm sorry. I'm sorry. Well, feel free to do algebra with the baby if that's okay. I'm okay with that. I have 3 kids. I get it. I get it. I get it. I really do. I wish mine were that little. Mine are teenagers now. They talk back. Anyway. All right. So let's do something a little different. So because y'all, if you've looked at your homework already, you know that you really have a couple of different kinds of problems. So let's look at this, and my instructions here are going to be rewrite as a function of x. And y'all, I've been teaching at the college for like 20 years. I'm getting really old. I've been there a long time. This scares people because they look at the instructions and they think, I don't know what in the world that this means to do. So they feel like they're kind of lost before they start. Don't let that confuse you. This is all that means. It's just fancy for saying solve for y. That's it. It means we're going to move everything around and get y by itself. Nothing else. Now, I am going to give you something that looks real ugly to start with, and we'll kind of see what we can do with this. But it just means get y by itself. So we're going to start with 3x squared plus 2x equals negative 2x plus 4y. Now that's long, I'll give you that, but they get longer in this course, so we're gonna have to, start working with some pretty big stuff. So the first thing I want you to know is, or wanna kind of say to everybody, you're really used to having y on the left side of your screen. This particular problem will be much easier for you if you will get y by itself on the right side of your screen, and that's okay. So this over here, I'm gonna kind of do that for a second. That is my only thing that has a y. So what I'm going to do is try to move everything else, which means I got to move that negative 2x right there. So what do I do to move a negative 2x?
Add it to both sides.
There we go. Okay. I'm going to put a little line right here. So we still have 3x squared because we didn't do anything with it. We just have to bring it along. I have 2x's on the top and I'm adding 2x's. Those are like terms, so we can combine them into 4x. These, I'm going to put an x through. It doesn't really matter how you show, but the negative 2x and the positive 2x cancel out. And then over here, I get 4y. Now we're almost done. The problem is that they said solve for y instead of solve for 4y. So we did this in the last problem. We're going to go through and divide every single thing by what?
4.
4. There we go. Okay. And then if you can reduce, you want to. If you can't, well, we're not going to worry about that. And so what we get, I'm going to write it over here, is we get 3/4 x squared plus, now here the 4 over 4 would cancel, so that would just be x equals, and here once again the 4 over 4 would cancel, would be y. So I'm going to circle this. This is what we get when we solve it for y, or as Hawks is going to say, when you rewrite it as a function of x. We get 3/4 x squared plus x. Now, unfortunately, this is one of those problems that teachers love and students don't typically, because this is only like part A. So let me give ourselves, actually, I'm going to move this over a little bit. Give me just a second. Well, I thought I was going to move it. There we go. Okay. And what they usually do for part B is they will say something like evaluate when x is, oh, let's just do 2. Okay. Now we can do anything we want to. I just picked 2. We could put 12. We could put 17.5, but that doesn't look like a lot of fun to me. So we're just going to do when x is 2. All that means is that you come down here and everywhere you see an x, you plug in a 2. So if we look right here, we see 3/4, but the next thing that we see is x. So I'm going to plug in a 2, and then I have to square it. Plus, and then I see another x, and I'm going to say plug in a 2. So all you do, and we're going to practice this again in the next problem as well, all you do is just take out whatever variable you've got and plug in whatever number they give you, and then you have to remember your order of operations. So I'm going to draw a little arrow up here so we can move up here to work. Your order of operations say that you have to always do your exponents first. So what we're going to do is we're going to keep our 3/4, and 2 squared, if you'll remember, means 2 times 2, so that is 4 plus 2. And then this 4 and this 4 are going to cancel out. And so that 3/4 times 4 is just going to give me the number 3 plus 2. And so my answer simplifies to be 5. Now remember, I just picked 2, and they're pretty nice to you in Hawks, but they aren't always going to pick the same number. So, you know, if you happen to be talking about your homework with a friend and one of you had the number 2 and one of you had the number 3, that's not that big of a deal, but you still work the problem the exact same way. You just take out your variable and plug in whatever it is you've gotten right there. All right, what do we think of that one?
I
Oh, got it. Yeah,
have a question.
absolutely. What you got?
You canceled out the 4 and the 4, but
We
I've been putting it over 1.
Okay, let's talk about that. It's the exact same thing, okay?
Oh, okay.
So look what happens. Actually, give me a second. Let me go back and erase this for just 1 second, and I'm going to put it over 1 exactly like you were doing. So we've got 3/4, and you put the 4 over 1. Am I understanding correctly?
Yes.
Okay, so then remember, when you multiply fractions, you don't need common denominators. You just multiply the top 2 numbers and you multiply the bottom 2 numbers. With me so far?
Mhm.
So that would give me 12, 3 times 4 over 4. And then I would still bring down my plus 2. Still with me?
Yes.
Now, what is 12 divided by 4 equal to?
3.
There you go. Plus 2, which still gives me 5. But now, listen, that's really important for you to realize for just a second. That work looks a little different than what I did. It is absolutely correct. One way is not any more correct than the other. It's not like you would get points taken off. It's kind of like I always tell students this. It's kind of like I'm saying, okay, everybody meet me at Walmart. It doesn't really matter how you get to Walmart as long as you get to Walmart. So as long as we got to 5, it doesn't really matter how you multiplied those numbers there.
So if the denominator and the times is the same, they just cancel each other out always?
They do, because of the fact that one's on top and one's on bottom. Yes.
Okay.
Kind of a cool fact, huh? But now, like I said, if you don't remember it, you can still get to your answer working through it the way you did too. All right. What other questions do we have on this? Any? No? Okay. All right. So let's do at least a couple problems. This next concept typically is something that students have a lot of issues with. And so we're going to do kind of one that's not as tough as the really, really tough one that you might see on your homework. And then we'll kind of get into the one that gets a little bit tougher. So, I think this is problem number 3. We're just going to call it that. I'm going to say, let's let h of x be 3x plus 2. And what I want you to do is I want you to find h of x squared. Now we're going to do a couple of these, okay? So here's the difference, really. If I were to give you, let's say, a number right here, and I'm going to replace this and put the x squared back in just a second, but if I were to come in here and say, hey, find h of 4, then I don't think as many of you would have trouble with this. What you would do is say, okay, well, my function is right here, 3x plus 2. So what I'm going to do is I'm going to say 3, but instead of x, whatever's right here is what I plug in for x. So I'm going to plug in 4 plus 2. And then you would just multiply 3 times 4 is 12 plus 2, and you would tell me that your answer is 14. And people don't mind that one as much, I think because it's numbers. But when I ask you to go back and do this, find h of x squared, people get a little antsy. And I understand it's a little bit more difficult looking, but we're doing the same thing. You're going to take whatever is right here, in this case x squared, and you're going to go up here to this function, I wish I could point, but I can't really do it on a whiteboard. So this one function up here, and you're going to write it down. So we got 3, but instead of my variable, this is what we plug in. We're going to plug in this time x squared plus 2. And then the catch really is 3 times x squared. There's really not much you can do with that. That's just 3x squared plus 2. And so a lot of times people feel like they've done this wrong because they think it's not finished. Because if you look at the first one where we said plug in 4, well, you got a number for your answer. But if you look at the second one where we say, okay, plug in a variable, then you also get a variable for your answer. And sometimes that really bothers people because they're expecting a number. But if we ask you to plug in a variable, you're going to get a variable in your answer. What do we think of that? Y'all don't sound as enthused on this. Okay, all right. Let's try this. I'm going to stick with that same H for a second. Okay, so give me a second. We're going to stick with that. And we're going to try one other thing. And then we're going to go to one that might get a little more difficult. And I'm sorry, I erased that equal sign. So there it goes. So this time we're going to try to find H of x minus 1. So this means the same thing. You're still using this function. So we're going to write it down 3, but instead of x, we're going to plug in that whole thing, x minus 1, and then we still have plus 2. And then this one, you do have to do something because you'll notice that x minus 1 is in parentheses. You have a 3 out in front. And if you remember, it starts with a D. It's called distribute. You have to multiply that 3 through. So in this case, we get 3x minus, and then the 3 times 1 would be 3, and then we still have our plus 2. But now you've sort of created a problem for yourself. If you look at these two right here, those are what we call like terms. One's a -3, one's a +2, and you can't leave an answer unless you've combined all your like terms. So this actually ends up being 3x, and then -3 plus 2 is -1. Everybody still happy?
Yes.
Yes, okay. All right, let's try the really hard one then. Let's see what we can do. All right, so we're going to change this. We'll call it problem 4 as soon as I can get all this stuff erased here. And problem 4 is going to probably take a little bit, so I'm going to try really hard to write kind of small. So problem 4. I'm going to change it from h to g of x, but that doesn't make any bit of difference at all. And we are going to call this 4x over x squared minus 12x plus 36. Oops, that doesn't look like a plus. Sorry, let me get my eraser in here. And we are going to have to find g of x minus 1. And I'll be honest, in my personal opinion, I think this is the most difficult homework question that we ask you because it has a lot more steps than anything else we've done tonight, and it has a lot more places for error. So what you have to remember is the principle is the same. Everywhere you see an x up in this little top equation right here, we're going to take it out and we're going to put all of this in its place. We're going to put the x minus 1 in its place. So the first thing that I see is a 4, but then I see an x. So I'm going to put x minus 1. And that's it for the top. So now we're going to move down to the bottom or to the denominator. And the first thing that I see there is an x. So once again, I'm going to put an x minus 1, but then I have to remember that that is squared. And then minus 12, and then we see an x. So once again, we're going to put an x minus 1. And then we see 36. And I did not quite make my fraction bar long enough. There we go. Okay, so that's the plug-in part. Unfortunately, now we have a lot of algebra to do, and we're going to have to do it in quite a few pieces. So the first thing that I want to do is I just want to look at the top. This 4 is kind of like that problem we just did. You're going to have to remember to distribute it. So that's going to be a 4 times x, and then 4 times -1 is -4. And then some of you, I didn't teach any of you math before this semester, so I'm not quite sure exactly how you learned math, and I'm not sure necessarily where everybody is kind of along the trail. So if you could maybe jump 1 or 2 of these steps, that's okay with me, but since I'm not sure, I'm not going to skip any single step at all. So what I want to remind you of first is that when you see this x minus 1 squared, that is really x minus 1 times itself, x minus 1. And we are actually going to have to multiply that out in just a second. We're going to do that. And then when you move to the next part, this -12 is kind of like that 4 up there. It has to distribute, but you have to be careful of the negative signs. So we have -12 times x. So that's -12x. And then if you'll remember, -12 times a -1 becomes a positive 12. And then I just have to bring down the 36. Now, I don't know about y'all, but it's looking worse before it looks better. Y'all agree? Yeah, I think so, right? Okay, so let's go over here. So if you look at the numerator, that's like the only good thing about this whole problem. 4x minus 4, there's nothing you can do with it. You just have to bring it with you. So the numerator is just 4x minus 4. That's it. We're just kind of carting it along, if you will. Now, when you come back to the denominator, we have to worry about this. X minus 1 times x minus 1. And I'm going to put off to the side, I know you have heard of this someplace before, but it's called FOIL. So remember, anytime you have 2 terms times 2 terms, we can FOIL them. It's pretty common. So what FOIL stands for, the first thing it stands for, F is first. So x times x. So x times x is x squared. And then O stands for outsides. That's these 2 things. X times -1. So that is -1x. And then the I stands for my insides. That's these 2 things. So that's a -1 times an x, which is another -1x. And then L stands for last. And so that's the last 2 thing in each parentheses. And so that is a -1 times a -1, which is a positive 1. There you go, because anytime you got 2 negatives, we've always got a positive. And that multiplied all that out. But unfortunately, it didn't deal with everything else. So I still have this minus 12x plus 12. And I'm running out of room, so I'm just going to kind of write it right here, sorry, plus 36. Now, like I said, it's ugly. So here we go. Let's keep working on it. The top is still 4x minus 4. That's the good news. Now, the bottom, the other good news is you are almost done. So if you look at the denominator, the first thing that you see is an x squared. There is no other x squared. So you cannot do anything at all with that. You just bring it with you. But remember, what you're doing is combining like terms. So I'm going to underline them. Here's a -1x. Here's another -1x, and there's a -12x. So you have a -1 and a -1, which is -2, and then minus 12 more, so that is a -14x. And then I'm going to come through here. I'm going to erase these real quick because I want to underline this. We have a +1, a +12, and a +36. And if you add those up, that ends up being +49. And then I'm going to do something that is a little different from Hawks. I actually pulled this problem out of Hawks today because I didn't really like what they did with the answer. So I'm going to circle that. That is an acceptable answer. It works. If you plug it in, it's perfectly fine. But if you were to happen to do something like look at a solution on this problem, this is what they do. they write 4x minus 4, and then they write over x minus 7 squared. And I have students email me about questions like this all the time. Here's what happened. I know Miss Young talked to y'all about factoring last week, and I know I talked about factoring, so I don't know if y'all watched that video or whatever, but all they did between this step and this step was they took that denominator and factored it. The instructions did not say you needed to factor, and so you don't have to. Now, if you choose to factor it, be my guest. That's fine. But if you choose not to factor it, that is also fine. You don't have to worry about kind of adding that extra step into that problem, because I think the problem is kind of long enough already. So I'm going to go ahead and circle both of these. They're acceptable answers. So I'll put a big or right here. One or the other works. You certainly don't need both, and you don't have to factor it. But if you look in Hawks, I wanted you to realize what they had done. All right, so let's stop right there for a second. What do we think?
I think I was confused on that question, but I got it eventually, and now you re-explaining it, I'm good.
You're good? Okay.
Yep.
All right, well, let me do this then. Those were the questions that I had prepared. So is there anything, and I know there's 4 of you in here and not everybody likes to talk, and if you don't like to talk, that's okay. You know, I'll be honest, when I was a student, I would never have talked across Zoom, so I get it if you're nervous or whatever. To be honest with you, it makes me nervous being on this side of it too. So, you know, we'll just all be in the nervous boat together. But I will be happy to answer any question that anybody's got. So does anybody have anything that you want me to talk about in our remaining time?
I do. I don't understand how to get the domain or range from just a graph problem.
Okay. Do you have a specific one, or do you want me to just come up with one?
You can just come up with one.
Okay, I'm going to do one that may be a little different than any one that you have seen in Hawks on your homework, but if you go through your learn and practice mode, you're probably going to see something real similar to it. And so give me just a second. Y'all know it's kind of hard to draw on these things. Sorry, kind of tough. So I'm going to draw a box here for just a second. And you know what? There's one other thing, now that you said that, there's one other thing I want to talk about on this problem as well. So we're going to answer your question, and then we're going to ask one more, okay? So here's a problem. It's essentially a square, but it's not perfect because I'm drawing by hand, so sorry, y'all. If you're unsure, because once again, it's not on graph paper or whatever, I'm going to give you the coordinates of each point. So the coordinates of this point over here would be 2, -1, because it goes out 1, 2 on the x-axis and goes down 1 on the y. This one would be 2, +1 is that top right corner point. This top left corner point over here is 0 on the x-axis and 1 on the y-axis. And then the bottom left corner point would still be 0 on the x-axis, but it's -1 on the y-axis. And if we give you something that is a closed figure like this, doesn't have to be a box, a circle or anything like that, knowing the outside points, the top points, the left, right point, the bottom point, all that kind of stuff is really important, because those are going to be your numbers that you use for your domain and range. So remember for domain, and that does not look like a D. So hang on just one second. Looks kind of like a funny little P. So your domain, I always want you to think left to right. And I mentioned it before, but it's worth mentioning again. It cannot be right to left. You have to start on the small side and move your way to the big side. So if you look, you'll notice my box never gets over in here, does it?
Nope.
The smallest thing that my box ever gets to on my x-axis, if I'm kind of moving in, like if I was driving on this, the first time I would run into my box would be right here. Well, what is that x value right here? Anybody know?
0.
0. There you go. Now, do you notice how I actually touched my box right there at 0? That's important because what that means is that I put a bracket right there because it means that my box actually touches that number that I just wrote down right there. And so that's important to know. Sorry, I didn't look like a 0 either. There you go. And then we put a comma. And the reason you always put a comma is because what a comma means is it means, hey, look, I'm going to get every single value up until when does my box stop? What number is that?
2.
2. And so what this means is my box covers every single number from 0 all the way to 2 for its domain. And once again, my box touches 2, so I'm going to close that. And the most common wrong answer that I get on, let's say I put this on a test or something, the most common wrong answer I get is people flip it. They'll put 2, 0. But you got to be real careful. I don't count off everything, but Hawks would, by the way. But you got to be careful to do left to right. And then for range, I want you to think bottom to top. So remember your domain is your X's. That's why you think left to right because it's your X axis. Range is your Y's. So that's why you think bottom to top because that's your Y axis. So once again, start down here at the bottom. If we come up this way, the first time that I run into my box is right here at this point. That point is what? -1. Now, people argue all the time and they say, and I don't mean the word argue as in argumentative, whatever, but they look at this and they say, hey, look, I got 2 numbers over here. I got 0 and I got -1. The reason that we call that -1 is because we are talking about range, which is your Y's, and this is your Y value. So you want to use that value. And then our box goes all the way up until what's the very highest point that my box gets to right here? 1. And once again, it touches it. And so that is my range right there. So my domain goes left to right. My range goes bottom to top. Now, one other thing that they may ask you on a problem like this is they may then come in behind that and say, okay, well, that's great. There was like your part A or something. But for part B, they might say, is this a function?
No.
Okay, and you are exactly right. The answer is no. Okay, we're going to talk about why the answer is no. They'll say, is it a function, yes or no? Unfortunately, guessing is not the greatest thing in math because, you want to have a reason for your answer. So the answer to that is this a function? No. And here's why. For something to be a function, it has to pass what we call the vertical line test. So what that means is that if you were to come in here and draw vertical lines, and I'm going to draw one up and down, you see how I draw this line right here? I hit this box in 2 places. Everybody agree with that? So this is not a function, and I'm going to say because of the vertical line test. I'm just going to make it right here. And I'm going to abbreviate because I'm going to run out of room. We typically call that VLT. Now notice it's a vertical line test. It's not the other way around, okay? So is it a function? Nope, sorry, because it fails the vertical line test because that means it hits it in 2 spots. Now really briefly, let me show you something. I'm going to erase my domain and range over here. Let me show you something that is a function so that we just can kind of have something to compare it to. So if I were to come over here and I were to draw something like, let's say this, okay? This actually is a function. And the reason that this is a function is because if you come in here and you draw a vertical line, we only hit that graph 1 time, right there. We draw this vertical line, I only hit that graph 1 time. Right here, I only hit that graph 1 time. So if you can draw vertical lines and you only hit that graph 1 time, then that means that it is a function. But if you draw a vertical line and you hit the graph twice, then it is not a function. Okay. All right, so let's stop right there. Does that help a little bit with domain and range from a picture?
Yes.
Yes. Okay. All right, what other question can we answer? Ooh, everybody talks at once, right?
That's the only one that I have.
Okay, so does everybody think they're set? I'm guessing that's a yes. Okay. All right. Well, then we're going to go ahead and we're going to call it a night. But I'm going to remind you. So if you have buddies in here or whatever, you can tell them that I'll put the recording to this out tomorrow, probably because I live in the country and uploading a 50-minute movie file is going to take a lot. So I'm probably going to wait till the school's internet because it's a whole lot better tomorrow. But remember, if you run into problems, you can always either stop by or send Miss Young or myself an email. We'll be happy to help you. Okay.
Okay.
All right. Y'all have a good evening. Bye-bye.
Bye.
Bye-bye.